let's start with the third. So we can here I define the axiom per serve, which inherits from both the derivative mixing and the simple XLP PC serve, and this is the Python built-in XMPRC serve, and the reading mixing upgrades it so that each incoming silence connection is handled in its own separate thread, and this means multiple silence can connect simultaneously without blocking each other. So because multiple threads might try to read or write the same XML file at the same time, I use the threading point look here. And this guarantees that only one thread assigns the files at any given moment, preventing data corruption. So this is, so then I have a note. This the first PRC method. It takes three parameters: topic, node title, and content. It searches for the matching topic elements in the Excel. If it doesn't exist, it press 1, and that is depends a new node element with the text and automatically generate timestamp. And get nodes read all nodes under the given topic and return them as the formatted string. This one calls the Wikipedia OpenSearch API to retrieve the title and URL of the first matching result. They automatically save it as a node by internally called the inNode REST function and calling it main. So finally, I register all three functions with the server. This will make them callable remotely, and the server maps the function name during its incoming XML to the actual Python functions. Now we will look at the silence. The key part is right here. So this line calls the serve proxy object, and this is the heart of XML PRC on the silence side. So when called proxy point a node, it doesn't execute anything local. Instead, it serializes the function name and arguments into the XML document, and send as the HTTP post request to serve, wait for the serve's HTTP response, and deserialize the XML response back into the Python value and returns it. So that is a completely set code of the remote and produce call. So for the low-level network failure, the silence display the friendly message instead of crashing. This is essentially any distributed system setting. Now we just I have opened the two server, and this is the so we can test for the function. Now we can select one and end the topic name such as Python and code and type. So yes, the silence response right, and after submit the input, silence print the message showing that RPC calling is being seen, and look at the server terminal on the left. You can see it logging on the incoming point result. That's the XML PRC message arriving on HTTP. The server execute add nodes and return the success message back to silent. Now we can test for two, and we should enter the topic name like yeah. So this I will search the and we have the text So the silence in the get node, PC record, and the serve reads from the XML file and returns all the nodes, which the silence then display, including the node title, content, and the timestamp that we generated server side. And we can try 3, and we can type AI. So we just have an URL. We get a website. We have on the server side, two things happened. Now we can see it's in the HTTP request to the Wikipedia observation API, and then you call the 8 nodes internally to see the results, and this made and the silence only made one RPC call, but the server performed a chain operation. So now we can show you the XML points. Here the XML database file. Every piece of data is stored in a well structured, properly indented formats with topic, node types, and timestamp elements exactly as required. So now we can stop this. Yes, the shutting. It was shutting down. So choose one again. Tap anything. But yeah, but it could not to connect to the server. So this attempts to send a PSQ, but the NAT is refused because there's no server relation. The trigger, rather than the crashing with the traceback, the silence catches the expectation and display a clear user-friendly message telling the user that the service is offline. So this is a fundamental principle distribution system. Yeah, so that's all of my display. Thank you.